Hello student, today we are going to discuss about this are the prism formulas we are going to see. Okay. So first one, a plus deviation is equal to I plus E, angle of prism, angle of deviation, incident angle, emergent angle. Okay. The second formula, refractive index is equal to sin I by sin R. That's going to be a plus deviation divided by 2 divided by sin A divided by sin 2. A is called angle of prism. Deviation is going to be a minimum deviation. Okay. It's called refractive index. And again, this is the angle of deviation. Okay. When the prism is thin, so angle of deviation is equal to angle of prism, refractive index minus 1. Okay. And dispersive power, we can write two equations like this. Okay. Today we are going to learn how to derive these are the equations from the prism. Okay. First we will learn prism. What is prism? Prism actually have the 5 faces. Okay. In 3-dimensional way, this is a prism. Okay. So 2 is a triangle and 3 is a rectangle. Okay. So the base we can take it as a rough surface. Other two rectangular side we can take it as a highly polished surface where the light can enter inside the prism, where the light can be go out from the prism. Okay. And this is called refractive edge and this is called angle of the prism. Okay. Angle A is always the angle of the prism. Equilateral prism, angle of prism is going to be 60 degree. Equilateral prism, angle of prism is 60 degree. Okay. Now when you are drawing the characterization, you can draw only 2D view, no need to draw with 3D view. Okay. This is a 2D view of prism. A, B, C is a triangular prism. Okay. PQ, QR, RS is called emergent ray. Okay. NO is a normal for AB, N dash O is normal for AC. Okay. And light, PQ is a incident light. Light supposed to travel like this. The light is traveling denser to rarer to denser medium. It deviate towards the normal. This is called normal. The light is getting deviated towards the normal. This side light is entering. Okay. When the light is coming out, the light is traveling from denser to rarer medium. It's supposed to come like this. Okay. Because of denser to rarer medium, it deviate away from the normal. The light finally is going here. Okay. Like this. PQRS is a light path. Okay. And angle I is called incident angle, R1 is called refracted angle. Always from the normal only, incident and refracted you should write. Okay. R2 is refracted with the another side. Okay. And E is a emergent angle. This is called emergent angle. Okay. The first light path getting deviated this much, that's going to be deviation 1. Second light path is getting deviated this much. Okay. From here to here, that's going to be deviation 2. Okay. This angle is equal to this angle. Okay. This and this, it's going to be same. Okay. This two angle will be the same angle of deviation. Okay. So addition of two interior angle will give the exterior angle, that's called total deviation. The point of D, it's look like a triangle. Okay. In triangle, addition of two interior angle will give the exterior angle, that's called the angle of total deviation. Deviation 1 plus deviation 2. Addition of two interior angle will give the exterior angle, that's going to be total deviation. Okay. Now I am going to write the equation. At the point of Q, I am taken angle of I is equal to R1 plus deviation 1. Okay. So at the point of Q, R is equal to I is equal to R1 plus deviation 1. This is a incident angle equation. Okay. If you want deviation 1, just R1 you can bring it as a that side. Okay. This is going to be deviation 1. Okay. Next, deviation 2. At the point of R2 I am taken this point. Okay. Like a cross mark is there, no, that alone I am taken. Emergent is equal to R2 plus deviation 2. This two addition will give us the emergent. The emergent I wrote like this. Okay. If you want deviation 2 is equal to emergent minus refracted 2. Okay. Deviation 1 also I got, deviation 2 also I got. Okay. The total deviation, addition of 2 deviations, it's going to be total deviation. Deviation 1 plus deviation 2. Deviation 1 already I know, I minus R1. Deviation 2 I know, E minus R2. Okay. I and E I made it separately because it's a positive. R1 and R2 is a negative. I am taken negative as a common outside. So negative times of R1 plus R2 will get. Okay. This whole thing from left side to right side, if you are shifting, this minus is going to become as a plus. Okay. Deviation plus R1 plus R2 is equal to I plus E. Like this we can get. Okay. In case R1 plus R2 I am taken as a A. R1 plus R2 I am taken as a A. So deviation plus A is equal to I plus E. Why I should take it? A is equal to R1 plus R2. Again, we have to look at the diagram. Okay. Why A is equal to R1 plus R2. Okay. See here, I am taken A, Q, O, R. Okay. This like a, this I am taken. It's going to be like a rectangle. Okay. So because of the normal, this going to be angle 90 degree, angle 90 degree. Q plus R, which is going to call as the 180 degree. Okay. Because it look like a rectangle. Okay. Q plus R, because it's normal, no, this also normal. Q plus R, which we can take it as a 180 degree. Okay. Same thing opposite, this and this angle A plus O will have 180 degree. So now what is A? A is equal to 180 minus O. Okay. So O, if you are bringing left side to right side, minus O we can get. Okay. Next thing, see from the diagram is a very important in a prism. Q R O. This triangle I am taken. This triangle if you are taken, R1 plus R2. R1 plus R2, angle O is equal to 180 degree, because one full complete triangle is going to be 180 degree. If you are taken this O that side, 180 minus O will be there. Okay. So already we know 180 minus O is equal to angle A. 180 minus O is equal to 180 minus O is equal to A, angle of the prism. Okay. So that means angle of prism is equal to R1 plus R2. Okay. One half of the equation is getting over. Okay. Now we proved basic prism formula. I plus E is equal to I plus E is equal to A plus deviation. This is the basic formula we learned now. Okay. Next, refractive index formula from the prism mu refractive index of A to G, 1 to 2, first medium to second medium, is sin A plus deviation divided by 2, sin A divided by 2. This is the equation we are going to prove. Okay, first of all, I am taken the air to glass only. The first medium is air, second medium is a glass. Okay, Snell's law, sin I by sin R. Okay, sin I by sin R, incident angle by refracted angle, that's called Snell's law. Okay, so when we are drawing the incident angle versus deviation, when we are drawing, the first deviation will get decreased, then deviation will get increased. Okay, when the deviation is become minimum point, that's time deviation is equal to minimum deviation. Okay, when the deviation is become minimum, that's the time QR is parallel to BC. The same time I is equal to A, R1 is equal to R2. This the condition should be satisfied when the deviation is become minimum. Only this is a place that condition will get satisfied. Okay, this 2 is equal and this parallel means you can tell that's a condition of minimum deviation. Okay, when the minimum deviation is there, already we have A plus deviation is equal to I plus E. Deviation is become minimum. Okay, I is equal to E. Okay, so I is equal to E. If you are adding this to 2 times of I is equal to A plus deviation divided by 2. This is called angle of incident. Okay, angle of prism is equal to R1 plus R2. This 2 also will be get equal at minimum deviation condition. 2 times of R we can get. Okay, so R is equal to A divided by 2. One more thing, for regular prism, it's a equilateral prism, it's an angle of prism 60 degree. R is going to be A by 2, that's going to be 60 divided by 2, almost 30 degree we will get. Okay, this also one of the fixed condition, refracted will be always 30 degree when the minimum deviation condition. Okay, R is equal to A plus A divided by 2, I is equal to A deviation divided by 2. Okay, this 2 we know from the prism. Okay, then we substituted the value sin I by sin R. I value, R value I substituted, I got like this. This is called prism refractive index formula. Okay, then I am going with the angle of thin prism. Okay, so I am taken thin prism, the prism angle is going to be less than 10 degree. Okay, it's a very small thin prism. Okay, so when this angle is small, sin theta is approximately equal to theta. Okay, so this is become theta, this become theta, 2 will get cancel, A will become as a cancel. Okay, so 1 plus deviation divided by 2. Okay, A will get cancel, 1 plus deviation divided by 2. 1 if you are bringing this side, refractive index minus 1 divided by A will be there, Okay, so that A if you are bringing this side, deviation is equal to A refractive index minus 1. Okay, like this will get, this is called thin prism formula. Okay, this is only applicable for thin prism. Okay, the next one, dispersive power. Dispersive power is equal to deviation of red minus deviation of violet divided by yellow. Okay, why it is red minus yellow divided by yellow, red minus violet divided by yellow. Okay, because minimum color, maximum color and center color. According to the color, green will be center, according to the wavelength, yellow will be the center. Okay, so yellow only you should take it. Okay, so based on this equation, just we wrote deviation of red, deviation of violet and deviation of yellow. Okay, this all 3 equations just I am going to substitute inside. Different color have different refractive index. Okay, once you substituted, angle of the prism is common, take it outside, angle of the prism will get cancelled. Okay, so minus if you are taken inside, minus refractive index of violet, plus 1 will come, minus 1 plus 1 will directly get cancelled, so remaining will be like this. Okay, this is called dispersive power of the prism. Okay, thank you for watching my video. If you like my channel, please subscribe. If you want more video, you can go and comment. I will do the concept which you are asking. Thank you, bye bye.